Good morning. How are you? Yep. I'm in my Chewbacca onesie. What? Drinking coffee out of my Chewbacca mug. Got all my toys. Woo! Nerd alert. So, we are now going to solve exponential functions. Woo! This is algebra after all, and it's all about solving, isn't it? Oh, how did those toys get there? I'm a nerd. All right. If you want to know what to get me for my birthday, there you go. I love collecting little Star Wars knickknacks. Okay, so here's the Wednesday sheet. There's 10 problems here. I'm going to do probably the first 6, and then I'll leave the last 4 for you to do and take a picture and put on Edmodo. So here's the deal. When it comes to solving these exponential functions, these bases have to be the same. Notice on number 1, they're both a base 6. All right, so if it's both a base 6, then you can just ignore those and focus on the powers, all right? Yeah, so when the bases are the same, cross it off, right? Totally ignore it. We don't need it. All right, so we're gonna focus on the a plus 2 equals the 2a minus 3. And we're gonna do some good old-fashioned solving. All right, I'm gonna move this a to the other side. Minus. Bring everything down, so that cancels. You have 2 equals 2a minus 1a is a minus 3. All right. Then I'm going to move this minus 3 over here, and you get 5 equals a. All right, so it turns out the intersection of this graph and this graph is at 5. All right, so if you've got your x-axis, 1, 2, 3, 4, 5, it's not where it's crossing the x-axis anymore. It's where these curves are intersecting. And I'm not totally sure what they look like, but something like that, where they intersect at this 5. All right, check out number 2. The bases are both 2. Oh, what a coinkydink. Number 2, the bases are both 2. Oh, all right. So we're going to get rid of the bases and just focus on the exponents, right? Focus on the powers. So we have 3v minus 1 on this side equals 2v plus 2 on that side. All right, when you're solving equations, I personally like to go for the smaller of the 2 variables. So that would be 2v, and I like to move that first. So the opposite of a positive 2v, a negative 2v. All right, 3v minus 2v is 1v. Bring down that negative 1, bring down the equal sign, that cancels, bring down the 2. All right. The goal is to get v alone, so we have to move minus 1. The opposite of minus 1, plus 1. What you do to one side, you do to the other. So we get v equals 3. All right, so what this is saying is that these 2 graphs intersect at 3. I actually have this one ready to go in my graphing calculator for you. All right, so I went to y equals and I typed in for the blue function 2 to the 3v minus 1. And then over here I did 2 to the 2v plus 2. So that's going to graph the red and the blue function. So there they are. All right, turns out they're intersecting at, we said v equals 3. So if I look here, 1, 2, 3, and I go up, sure enough, right, they intersect when we are at 3 on the x-axis. All right, so that's what we're doing in these problems. We're finding the intersection. All right, so let's take a look at number 3. Number 3, how dare you? How dare you, sir? The bases aren't the same. I can't just scribble out 4 and 16 like I did up here with the 6s and the 2s. So now I gotta get a little creative. I need to think about a way that I can turn 16 into something with a base 4. All right, that one's actually not so bad because 4 squared is 16, right? 4 times 4. So I'm not changing the value at all. It's still 16. I'm just, putting its hair in a ponytail. Look at that beautiful ponytail. So we have 4 to the 2x here and 4 squared here. Now that your bases are the same, you can ignore them and focus on the powers. So we have 2x equals 2, right? If we didn't do that change right here on the 16, we wouldn't have known what to put this equal to. All right, so the algebra on this one, not so bad. All right, what's the opposite of times 2? Divide 2. And what you do to one side, you do to the other. Good job. So then you get x equals a 1. So it turns out that this intersects if you graph 4 to the 2x and you graph the horizontal line 16, it intersects at x equals 1. All right, so let's check out number 4. Okay, 6 and 216. Oy. All right, we need to figure out how to turn this into something with a base 6. All right, how are we going to do your hair today, 216? Well, let's play around with it, shall we? 6 squared is definitely not 216, right? 6 squared is 36. So how about I try 6 to the 3rd? Ha! Found ya! All right, we can rewrite 216 as 6 to the 3rd. That way we haven't taken away any value. It's still 216, but, you know, with its hair in a ponytail. Yay. All right, so these bases are the same. Focus on the exponents. So you have 2k plus 1 on the left, and you have 3 on the right. Time to solve. The opposite of plus 1 is minus 1. What you do to one side? That's right, Chewbacca. And you get 2k equals 2. The opposite of times 2 is divide 2. And 2 divided by 2 is 1. All right, 1 again. That wasn't on purpose. All right, let's check out number 5. We have a base 5 and then 125. All right, so let's think about this. 5 squared is not it. 5 to the, whoops, wrong button. 5 to the 3rd, there it is. So we can rewrite this as 5 to the 2x equals 5 to the 3rd, right? Because 5 times 5 times 5 is still 125. So we've just given it a new hairdo. Nice. All right, the bases are the same, so ignore them. Focus on the powers, 2x and 3. We want to undo this here. So what is the opposite of times 2? Divide 2. That's right, that's right. So we get x equals 3 divided by 2. It's a decimal. I'm just going to leave it as a fraction. All right, if you want to turn it into the decimal, go for it. That was weird. All right, number 6. We have 2 to the 3x plus 3. Right. How am I going to turn that into something with a base 2? Use the force, Hamilton! Use the force! Actually, Yoda probably wouldn't have sounded like that. He probably would have been like, the brain you will use, yes? Thoughts you must have, okay? It's more of the, you know, Obi-Wan that's like, use the force, Hamilton. Enough of that. Okay, so here's something that you might not remember from properties of exponents. What is 2 to the 0 power, right? If I raise it up to the 0 power, what am I going to get? You're going to get a 1. Interesting. So 3 to the 0 power, you get a 1. How about 3, 5, 2, 6, 4, 1, 0, 2, 8, 8? I made that up. To the 0 power, guess what you get? 1. So what you're trying to say is your mom to the 0 power is 1? That's right. Anything to the 0 power is 1. So the haircut we could do here is pretty simple. We could do this style, 2 to the 0. 2 to the 0 is 1. And now we have the same base on the left as we do on the right. So we have 2 to the 3k plus 3 equals 2 to the 0. The bases are the same, so we can ignore those. We get 3k plus 3 equals 0. All right, so how do we move positive 3? Beep, boop, beep, boop, boop. That's right, minus 3. And what you do to one side, boop. That's right, you do to the other. So you get 3k equals negative 3. Then the opposite of timesing 3 is dividing. Alrighty, so negative 3 divided by positive 3 is negative 1. That, my friends, is the intersection of these two equations. Alright, so I'm going to leave 7, 8, 9, 10 for you. If you don't have a printer, don't worry about it. Just do it on a plain piece of paper, take a picture, and submit it on Edmodo. And that way I can make sure you're doing okay with all this stuff. Sure do miss you guys. Hope you're staying sane, because apparently I'm a little bit insane. But you knew that.